Our first talk is about Druid roadmap and the future of Druid that Eric Tschetter from Imply will be presenting. Eric has the honor of writing first lines of code for Druid. He is also responsible for many of these fancy variables names that you may come across in Druid codebase. While Eric is not based out of India, he's not too far away either. He's based out of Japan and is the field CTO at Imply. He also works with Druid India as an architect and guides us in all Druid related features and problems that the team here is trying to solve. So with that, over to you, Eric.
Thank you. Can everyone hear me? Well, I guess, Abhishek, can you hear me since you can talk?
Yes, I can hear you.
Great. Let me go ahead and share screen, get this and start presenting. Okay. Abhishek, thank you. Thank you everyone for having me here. As Abhishek mentioned, my name is Eric Tschetter. I wrote the first lines of code in Druid many years ago. I am currently working as the field CTO here at Imply. We work on Druid, do all things Druid all the time, pretty much. Before Imply, I've worked at Yahoo doing stuff with Druid. I worked at Splunk doing stuff with Druid, and before that, MetaMarkets and other places like that. But today, I would like to talk about two things basically. Well, three, I guess. One is the 0.22 release, which happened back in September. I'm just going to go over a little bit of those features, spend a little bit of time talking kind of the future of Druid, where we're planning on taking it, what kinds of things we're planning on doing. And then lastly, how to join in. So jumping right in, the Druid.22 release happened September 22nd. Lots and lots of different contributions, lots of things to kind of point out and talk about. Just going through some of the top level things. There was this array ag added, which basically adds support for kind of operating on arrays. And this is kind of a foundation for more and more support for more complex kind of data types. And you can see an example query here using it where an array was built out of the distinct values of one dimension, and then an array contains filter is used to then filter another query on those distinct values. Additionally, something kind of similar, there was a string ag also added, which you see an example here where there's this L1 column that apparently has 325,323, and a bunch of zeros in it. And the first simple string ag just concats them with a dash, and so you can see that on the left side. And then the second one actually does a distinct and then concats them with a comma, and so you can see that one, they ended up sorted in order to do the distinct, and two, there's only 3 instead of all 6 rows. There was the addition of a bunch of bitwise operations. You can see them all there. They do what you expect for bitwise things. Also, there was the addition of this native expression aggregator. And this is kind of an evolution of many years ago, there was a JavaScript aggregator, and it actually still exists, but it's generally turned off by default because it opens up some security holes. JavaScript running in the JVM has it opens the door to various security problems. It's not sandboxed very well. And so generally we recommend to turn that off. But this expression one is kind of similar in that you can write your own kind of aggregations ad hoc when you're just writing your query. And so if an aggregation doesn't exist in Druid, or you're trying to get something that you want to push down, you can write it as an expression using one of these aggregators, push it down, and it'll do a relatively decent job of doing it in performance. Of course, writing something native is always the most performant option, but sometimes when you're just iterating, it's nice to be able to just play with values, play with a quick iteration of things. And so this can be a nice tool for doing that. Next up, the JDBC connection. we've added support for protobuf serialization. This just basically it's an optimization for the result set, the communication back and forth when talking over JDBC. You can turn it on with the URL like you see here, where you say serialization equals protobuf. Also, for native ingestion, when using the native ingestion jobs, there's multiple stages of jobs. Each one kind of generates some artifacts, and by default, those artifacts stay local to the middle managers and peons. But with the support for deep storage that was added, you can have that stuff pushed up into deep storage, and then have the next jobs pull down from that, which gives you an added kind of level of availability, so that even if you lose a node, you don't lose the intermediate state that was persisted on it. And then also for native batch, there were some optimizations that went into kind of how memory is managed. Some of the metadata objects that were tracked were using a bunch of extra memory. And so there's some options now for how to control that. And that kind of does it for a real quick run through of some of the stuff that was done in Druid.22. A lot of this is, it's kind of a baseline foundational work to help build more and more things. Like you saw the array ag and string ag, those are showing more work with more complex types like arrays and the things you can do with them. The native expression aggregator as well, a number of things like that. And so that kind of works as a segue into one of the things that I'm most excited about talking about, which is the future of Druid. Where are we taking Druid? What do we want to do with it? Where do kind of we see the roadmap going, and in building Druid into be the best thing that it can be. And for this, one of the kind of high level themes in a lot of the work, at least that Imply is doing for Druid, is in simplifying the configuration and simplifying the operations. One of the things that we've heard in feedback from people is with Druid, there's a lot of different configurations. Some parts of the system have more configurations than others, but across the whole, there's a lot of different configurations, and a lot of times that can be really powerful when you run into an issue and you want to fix it. There's often a configuration option to do it. At the same time, you have to kind of know about these magical configuration options to know how to actually react to things and do things to fix issues. And so we're trying to make it so that you don't have to know about magical configuration options. They just kind of work, things work and just out of the box. And so that's one thing. The other one is working more and more. So Druid started in the cloud. It's been cloud native from the beginning. There's always been an understanding that your machines are ephemeral. They can go away. You need to maintain stability, maintain operations, maintain availability, even in such an environment. And so we're doing more and more work towards expanding that to where there's more support for auto scaling. There's more support for kind of dynamic adjustment of resources, being able to add resources or add processing power in response to a query coming in, and stuff like that more rapidly. And these are kind of two of the high level themes. One of the things that, there we go. Okay, wait a second. Okay, here we go. One of the things that really gets us towards that, we think, is extending the actual SQL API. And one of the goals for this is we're trying to build one SQL-based API for all of Apache Druid, where right now we have the SQL-based queries. We're looking at adding SQL-based ingestion, SQL-based transformations, all to Druid to make it more powerful, more simple, connect it together with the things that everybody kind of knows with SQL. If we can remove the JSON specs, simplify some of the configuration. We're not actually removing the JSON specs, but we're making it so you don't have to write one. You can just write it with SQL instead. So some examples of this is you can have an example here on this is my left. Everyone's probably looking at the same screen, so it's on the left, where you see the JSON objects, and this is a JSON ingestion over here. And we can turn this exact same JSON ingestion into this simple SQL query over on the right side, where it's just insert into a new data source, select all the fields and add this new protocol one from a table, and you see this extern thing where it's actually pulling data from an external source. And so this is this is kind of our thinking and thought process around what we can do to make ingestion super simple. Is we can represent all of this stuff via SQL, reduce all the tuning parameters. Once it's via SQL, you get to take advantage of things like joins, enriching the data, all of the familiarity and everything else that comes with that. There we go. So here's another example. And this one you can see actually running a little bit inside of the Druid console, which anyway, you've probably seen at least some point in time. And here, once again, you can see an insert into selecting some values from this table, this extern table, which has basically it's specifying a source from HTTP and getting the data out and doing all of that. So this is just another example of kind of taking it, representing this stuff via SQL and running with it. And so why are we doing a lot of this stuff? And it all boils down to what we've heard from developers such as yourselves about what do developers want to do with their analytics app. So we start with interactivity, and this is the thing that Druid is kind of known for. Really fast responses, lots of data, lots of queries at the same time. And Druid was built for this. We started kind of in the ad tech world, working on auction data streams. Since then, it's expanded to be used in almost every industry, or every industry that I can think of. At least I can think of people who are using Druid. And so this is kind of where Druid started and where we're strongest. What we've found is that as people get data into Druid and they use it for this, they end up having other needs that they also want to use Druid for with the same data. But some of the ways in which Druid is set up right now can make it a little bit more difficult to do those other things. And so one of those examples is reports. So with reports, traditional reporting use cases, you have very large result sets, long running queries. You can wake up at the end of wake up in the middle of the night, run a query. If it takes an hour, 2 hours, it's okay, because what you really want is that report to be built and an email to be sent to someone or something like that. And these queries are CPU heavy, but don't actually happen all that often. And this is one of those requirements that after people get set up with their kind of data application, they get data in Druid, they want to also use that same data for reporting. But the way Druid's set up with kind of always on infrastructure, the optimizations that we've done to make it super fast and highly concurrent also mean that, or traditionally they have meant that it takes a little bit longer to spin up extra resources. And if you send these extra queries, like reporting queries, to the same infrastructure that's, say, supporting your production systems, you're now fighting for CPU and resources with those production queries, and you run risks of kind of knocking them over or impacting your production experience. And so people right now tend to work around this by dual loading with another engine. They'll have the data also in something else and do these reporting queries with that. Another requirement is alerting. And with alerts, people usually define many millions of alerts, where when I say millions of alerts, what they're actually doing is defining one alert across a whole bunch of different values of 1 or 2 dimensions. They're tracking large numbers of objects, and they have complex conditions. Like if it goes over a threshold for 5 minutes and it stayed over the threshold for 3 hours, then actually alert, otherwise don't alert, and things like that. And the ways that people deal with this is you either try to do it in Druid because the data is there and it works, or people will sometimes go and add a stream processing engine to their architecture and start doing this processing with that. And so these are some of the other requirements that we've seen people need to do with their analytics applications. And we see Druid as very squarely fitting in this analytics application world. And so we're working to expand it to be able to handle these other requirements more directly and natively. Saying this another way, we have the core Druid, which is kind of the always on, prefetches data to minimize movement, always on compute, ideal for interactive high concurrent queries. And then we're adding this future decoupled query layer, which is some of the stuff that I talked about a little bit earlier, where we're adding this extra query layer that basically integrates seamlessly with the data that is already in Druid. And so it can be a separate compute layer for on-demand CPU resources. Given that it's built 100% for on-demand CPU resources, it's built to be able to scale up and down really quickly and really rapidly. It's ideal for these kind of large result set type of workloads that are not interactive and also don't happen that often. So you don't have to pay for the infrastructure to support them just because that query comes once a month or once a week or something. Anyway, so this is kind of where we see Druid going. These are some of the ideas we have for what we're trying to do. Just to reiterate, we're simplifying, removing configurations, making it so that stuff's handled more directly, doubling down on SQL, doing more with SQL, being able to pull data in with SQL, transform it, adjust it, as well as do the query. And then more of this work on this decoupled query layer that can more elastically scale out and handle arbitrary the non-interactive workloads and handle some of that sort of stuff. So next, how to join in. If you're interested, I assume everybody here is already interested in Druid, so this is probably not new information, but you can find the project. You can always join in. It's open source. We welcome anybody to come chat, talk, work on whatever. Also, another way to join in, given that I work for Imply and do all of that, we're hiring at Imply. If you're interested, you can talk to us, reach out to Abhishek or whatever, and we can talk. But that said, thank you. If there's any questions, I can take them. We can talk through them.
Thank you, Eric. Note to everyone, you will be able to unmute yourself. So if you have any questions, feel free to do that. Just unmute yourself and ask anything you want.
Eric, hi, Kundan here. So I wanted to know about, are we doing some more optimizations related to real-time, the peon processes there? Because what I have observed personally is that we have this segmentation done already that is in historical, the peons are not up to the mark that we were expecting. The historical segments were pretty much fast for serving, for large concurrent requirements, but peons lag sometimes, means after a certain period of time, when they start lagging behind. So are we working on these peon segments in future? Are we planning to release something specifically for peons?
So if I can repeat the question to make sure I understood, you said that you've experienced like performance and concurrency results where you're getting what you expect from the historicals, but you believe you're running into bottlenecks in the peon processing of handling queries in order to respond to things.
True, yes.
That, okay. So the specifics, to answer your question, I'm going to give you a cop-out answer. And the answer is there's various things, and this gets back to the tuning parameters that were mentioned earlier. Right now, for what you're talking about, there are various scenarios where adjusting some tuning parameters can have a significant impact on that sort of thing. You mentioned that you experience it after some amount of time, which might actually mean, it could mean a couple of different things. What I've most commonly seen in scenarios like what you're talking about is one of two things. Either one, sometimes the tuning parameters for how much data to keep in memory can be set such that segments are persisted actually too often. And so the peon actually, as it's doing ingestion, it builds up data in a buffer in memory, takes that data, persists it to a segment, and then when queries come in, it runs the query against all of the segments it's persisted so far and what's in memory. And if the settings for what to store in memory, like it's a weird balance, because if it's set too large, then that can slow down the query because the processing on the in-memory stuff is not as fast as the processing on the segments. And so you don't want it too large. But also if it's set too small, you can get too many segments. And now you end up spending a lot of time and overhead in merging those segments together, which also can slow down the queries and do things. And so there's a fine balancing act to do there. One of the big things that we've seen in these tuning parameters is, I forget exactly when, but we added a we added a tuning parameter, which is trying to estimate the number of bytes used on the JVM before doing the persist. And depending on the way you're ingesting the data, that estimation can be pretty bad sometimes, to where it actually causes you to persist a lot more often than you need to. And one of the things that we're working on very directly is fixing that to make that estimation better, which should then mean that you don't have to care about that configuration anymore, and just makes the world a better place. But that's assuming that that's kind of what you're running into. That's the answer. There's a long one. Sorry.
No, I got you. Just to add over it, on top of it, this is correct, right? That bitmaps will be used by peons as well. So when we are collecting data in peons, it is related. The bitmaps are also used over there.
Yeah, the bitmaps. So the bitmaps are built when the segment is persisted. And so bitmaps exist when it's reading the segment that it persisted out of memory. It's using bitmaps for that, or it uses the bitmaps when it's doing the filtering there. When it's processing the buffer, the stuff that's buffered in memory, it hasn't built the bitmaps yet. And so it doesn't actually have bitmaps available at that point in time. And so that's the reason why, if the in-memory is too large, it can slow down queries, because there it doesn't have indexes, it's just scanning over the data. But the belief there is, given that it's all in memory, it's all just pure JVM memory, that scan should be relatively fast. And usually it is. Once it's been persisted, then you have the bitmaps. But if the setting that causes the persist to happen is set too low, you could easily build up 1,000 like little tiny segments of 1,000 rows a piece. And when you're now going across 1,000 independent like segment files, each with their own independent bitmaps that are only a bitmap over 1,000 rows, you end up getting pretty slow performance because you have too many of them. And so that's kind of the balancing act there.
Thanks, Eric, for your answer.
Yeah.
We have one question in the chat. Kalen, do you want to just like read your question? Or shall I do that?
Yeah, I think you can do it. It's a bit noisy here.
Okay.
Sorry.
So the question is, moving from JSON to SQL-based format might be restrictive because SQL always says what to do, insert, select, etc., but not how it needs to be done. Do you think it will be more restrictive and leading to creating more configs than?
So the goal is to create less configs. Hopefully it doesn't create more configs. At least the short to midterm implementation is going to remain SQL gets parsed, planned, and turned into native. And the native JSON thing is kind of what's actually running. And so that means that there's always the kind of escape hatch of going to the JSON object, writing a native JSON object and submitting that to do what you need. And so there is definitely room for kind of doing things that don't always fit the mold of SQL through JSON objects. I think it's our intent to basically leverage JSON to do new and interesting things that we don't know how to connect up with SQL yet. But then over time, once we know that it's good and useful, we'll then go and figure out how to make it show up in SQL. And so no matter what it is we're doing, sometimes we might do something in the native land first and then figure out, okay, we know this is useful, we know it's good, it's not just some random idea, so let's figure out how to make it show up in SQL. And so I think that's something that will happen kind of over time. But yeah, so hopefully it doesn't lead to more configs. That would be an unfortunate outcome if that's what happened.
Thank you, Eric.
Thank you so much. Hope you have a great weekend. And yeah, thanks for coming and presenting.
It was a great talk, Eric. Thank you so much. Let's move to the next one. We have